So this is lab 3 with the magnets. So in this video, I will go over the problem statement, foundational ideas, and a summary of my results, discuss the experiments in the lab, and explain the calculations and results, and then provide a summary of my GlowScript code. So in this lab, we wanted to measure the distance dependence of the magnetic field due to a small bar magnet and compare measurements to the distance dependence predicted by the equations for the on and off axis magnetic fields derived from the Biot-Savart law. So some of the foundational ideas are the Biot-Savart law, which is that constant times 1 over r cubed, and then 3 times mu times r minus mu. And then we've got the magnetic field of the bar, which is k r to the n, and then that equation of the line using natural logs. And then the summary of my results, well, my equation was y equals negative 2.9x minus 13.849, where negative 2.9 was n, and my off-axis magnetic field was 49. So some expectations and assumptions were that the Earth creates magnetic fields, the bar magnets act as magnetic dipoles, and magnetic fields increase close to the source. In the experiment, we used a dedicated magnetometer app to measure the magnetic field due to a permanent dipole magnet, and as you can see, there is a image that provides a visual of how the lab was conducted. So for my calculations, some of the important values were that constant being 1 times 10 to the negative 7. For calculated results, natural log of k came out to be negative 13.849, that y-intercept. My n value was negative 2.9262, and mu came out with some rearranging of an equation to be 4.84. And as you can see, there is the data for the off-axis field on the bottom. So for my GlowScript code, first we had to create a function for the magnetic field as seen right up here. And then we had to write code for the observation locations, 2 on axis and 4 perpendicular to the axis, to set up the arrows in the model. And then finally there was the 45 degree angle part of the model as seen below. So this is an image of my GlowScript model. The orange arrows represent the magnetic field on axis. The blue arrows represent the magnetic field when perpendicular to the axis. It calculated distance as 0.283738, which was close to what my hand calculated values gave me. And as you can see, the magnetic field at a 45 degree at distance d came out to be 1.0594 times 10 to the negative 5th in the x direction and 3.178 times 10 to the negative 5th in the y direction. And there is a link to my GlowScript code. In conclusion, if we hadn't oriented the experiment to compensate for magnetic north and how the results would change, Earth's magnetic field would strengthen or increase the x component of the magnetic field, so all of the measurements would have been altered. And if we were to stick two identical magnets together and run the experiment again, the magnetic field would double.